2.2, thank you. So what do you get when you take just 1.7 times 2.2?
3.74.
374, excellent. Okay, now go into your calculator and do the actual square root of 3 times the actual square root of 5. So you gotta use that second key, right? Second, and then the x squared. And then your, oh, not there, like, no, do it there, do it on your regular screen. Second, there you go, that's what. Okay. Oh, so now you do the second and then the square root, 3. And then use your arrow to move over, because otherwise you're gonna end up with 3 times 5 underneath the radicand symbol. And then do the square root symbol again. 2 seconds, quick. You don't have the actual square roots, huh? Okay, well, you can write off of what Raven's got there for now. Is not coming out? Oh, you don't, yeah. Don't even ask me for help.
It's the same thing, I just
Is
need
it really?
to have the instructions,
You know,
because I wasn't there for the first time I did it.
Joan and I were working in Mr. Peak's shop this weekend, making some cuts, building a windshield for the new boat. And,
On wood?
no, out of 3/8 inch Lexan. Piece of Lexan this big cost $200. Believe me, we were very careful with our cuts. We tried to make no mistakes, and we didn't. And we had to cut triangles, and we had to do a bunch of, moderately heavy geometry. And we were just trying to use, like, on the phone calculator, and it wasn't working. It was a wreck. So we ended up having to go online and find something. So you get 3.74. So now if you do this, in order to enter this, you're going to do the second key and then the square root key, which is the same as the x squared key. And then you have to use your arrow over to the right. And then you will do the multiplication key. And then you'll do the second key and the square root key. And then you're going to enter in the 5 and then the equals key. And that will make it work. So are you getting 3.74? Does that make sense? 2 times something a little smaller than 2
Yeah.
should be a little smaller than 4. Okay, what happens when you do the square root of 3 times the square root of 5? What do you get?
3.87.
3.87? And it keeps going, doesn't it? It just fills up the whole screen. How about you? Are you getting something like that? Okay. Now, we're probably a little low because we didn't use enough place values here. But if you had to use more place values, you get it a little bit closer. Now, I'd like you to do this. I would like you to enter, so this is square root of 3 times the square root of 5, right? I'd like you to enter the square root of 3 times 5 in your calculator. So you're going to do second function, radicand, 3 times 5, and then hit equals. What do you get? No way. Impossible.
Yeah, so I got that. Yeah.
Really?
Yeah.
Wow. So you got the same thing, huh? So what does that tell you about square roots? Let's add one more piece to the puzzle. Let's do the square root of 3 plus the square root of 5. What do you get?
It's just a little higher.
A little higher, huh? 3.96.
9.6.
Okay, let's do this. Let's take the square root of 3 plus 5. What do you get there?
2.82.
2.82. I don't see you guys pounding on your calculators. Are you stumped? you have it? You keeping up? You want help keeping up? So here's a question. If numbers are added underneath the radicand symbol, can you separate them and take the square root of each and get the same number? No. What if they're being multiplied underneath here? Can you separate them? Yeah, that you can do. So let's take another possible combination. Let's take some square roots that we know. So for example, the square root of 25. How much is that? That's 5. And let's multiply that by the square root of 16. What's the square root of 16? 4. So what's 5 times 4? 20. Confirm that with your calculator. Do the square root of 25 times the square root of 16. You got 20? All right. So off on the side, what's 25 multiplied by 16 anyway? It's a big number. Is it 400?
Yeah.
That's 400, isn't it? Okay, so let's do this. If we thought of 25 times 16, so now we're multiplying square roots, and we take each of those and we bring them together. We multiply the 25 and the 16. What's the square root of 400? It's also 20, isn't it? So what this does is it leads us to the next little property that we have. And the next property that we have is the product of square roots property. So remember, we have all of these, the power of a power, power of a quotient, and all that stuff. Well, this is the next one here, product of square roots property. And this one gets used a great deal. If we have two numbers that are multiplied together to make something, to make some big number, or even a small number, what we can do is we can take the individual factors, in other words, the numbers that multiply together to make it, we can take it and find their individual square roots, and it's still going to do the same thing. So the example that we have here was like the square root of 25 multiplied by 16, which is the square root of 400. And that's equal to the square root of 25 times the square root of 16, which is 5 times 4, which is 20. Let's do some other ones on your calculator. I'm going to erase a bunch of this. So let's take a fraction like 25 over 4. I'm sorry, 25 over 16. 25 over 16. These are the bigger numbers. Let's do this. Let's take that square root. But first off, I'm going to ask you, can you simplify 25 over 16? Can we reduce the fraction? Because this is just 5 times 5. This is 4 times 4, which is 2 times 2 times 2 times 2. So there's no common factors. So in order to put this into the calculator, you want to do second. And then you're going to do your square root key. And then, I'm trying to think with these, if you need to put parentheses with the 25 over 4. Let me just take a look. Let's see, it'll show you what it's trying to do. Nope, you just type in 25, and then division, and then 16, and then you should get, how much? What do you have? 1.25. Okay. So let's do this. Let's separate the 25 and separate the 16. And the reason that I'm doing that is because, actually, before I even do that, I'm going to do that in 2 steps. Here's what I'm going to do. First of all, I'm going to say that 25 is the same as 5 times 5. Agreed? And 16 is the same as 4 times 4. And I chose 4 times 4 and 5 times 5 because those are square roots of each of them. So in this case here, if we use the idea of the product of square roots, we'll use that idea in the top here. We could think of that as the square root of 5 times the square root of 5, which is still equal to 5. And we can think of this as the square root of 4 times the square root of 4, which is equal to 4. So really what we're doing is we're taking the square root of 25 and we're dividing it by the square root of 16. So this is 5 times 5, it's 5, this is 4 times 4, which square root is 4. And 5 divided by 4 is 1 1/4. So what this does is it leads us to the next property. It's just an extension of the product of square roots. We call it the quotient of square roots. And it says this, if I have, oh gosh, how do they do it with? They do it with C and A, so we'll just write it that way. Square root of C over the square root of A is equal to the square root of C divided by A. And in this case here, we can't have A equal to 0 because we can't divide by 0. We can take the square root of 0, which is 0 times 0 or 0. But we can't divide by 0, so we don't want to use that. So those are the 2 properties that they're introducing with this lesson. And then, how do we use these properties? That's what the examples are. So, here's the first example. They want you to simplify the square root of 27. And it's like, use one of these properties to write that more simply, is what they're asking us to do. Any ideas? Yeah, then you get those ugly decimals, right?
Yeah.
We want to stay away from the ugly decimal numbers. Everything's going to be integers when we're done. Here's your strategy. When you look at 27, can you write that as a product? In other words, 2 or more numbers that are multiplied together. so that one of those numbers is a perfect square. 3 times 9, there you go. So, square root of 27 is equal to the square root of, I'm gonna write 9 times 3, okay? You can write 3 times 9, that's fine. Then, using the property, we say, well, that's the square root of 9, and that's the square root of 3. So what is the square root of 9? It's 3. So this becomes 3. We read this morning. We read this 3 root 3. Which is the same as 3 times the square root of 3. Because that's what we've got here. We've got the square root of 9 times the square root of 3. So this is 3 times the square root of 3. And then the square root of 3, can that be further simplified to be multiplied by a perfect square? It can't be. So this here would be the simplified form of root 27. Or the square root of 27. Sometimes we'll just say, oftentimes I'll say root 27 because it's a lot of time. But what if we did something like the square root of 800? We want to simplify that. Can we now write that as the product of other numbers, one of which is a perfect square? You're nodding your head. What do you see? Do you guys remember the perfect squares? 1 times 1, 2 times 2 is 3 times 3 is 9. 4 times 4 is 5 times 5. 6 times 6. And then what? 49. 64. 81. 10 times 10. It's 11 times 11. 121. 12 times 12. 144. Then they get kind of weird. 13 times 13. 169. 14 times 14. 196. 15 times 15. 225. Good. It's under with that. And I'm going to stop there because I don't know them after that. I know a few of them, but these are the biggies right here. Really big up to there. That one and that one come out a lot. This comes out. 14 squared doesn't come out too much. 15 squared happens in problems. So are any of these numbers factors of 800? So can I write the number 800 as multiplication by 2 or more numbers? One of those numbers comes from this list. 100. 100 times how much? 8. Okay, so then the square root of 100 times the square root of 8 is the same as 8 this. So what is the square root of 100? 10. So I'm going to put that here. So this is 10 times the square root of 8. 10 root 8. Same. But what about 8? Can you write that as 2 factors? One of the factors is one of these perfect squares. Which one? Which one? 4 and 2. So we take the 4, now we've got 10 times the square root of 4 times the square root of 2. And the square root of 4 is how much? 2. So this becomes 10 times 2 times the square root of 2, which is 20 root 2. And then you're done. That's simplifying square roots. So as you go further into your math, you'll be doing more calculations that involve square roots, like with the Pythagorean theorem, for example. And if you need to get exact answers, and we end up keeping the square root symbol because the square root of your answer is not a perfect square, then we're expected to simplify them. Because this is a whole lot easier to picture than this. And the reason it is you remember back in 7th grade, I went through estimating all of the perfect squares. I'm sorry, not the perfect squares, but the square roots in between, like 1 and 25. I think we went through all of them. Well, the square root of 2 is a little bigger than 1, and it's smaller than 2. It's about 1.4. Well, 20 times 1.4 is about 28. So this is about 28. Look on the calculator, what's it equal to?
28.28.
How much? What did you get?
28.28 and so on.
And it goes and goes and goes and goes. So we can get a mental picture of what this number is and have it still written like this. And as we go further and further in math, we use numbers written like this to do calculations. You'll be doing more and more of that. So that's the purpose behind this. So this is a skill that we're doing a little bit of practicing with this example. So a little bit of application of it. Think of a triangle. Each leg of the right triangle is 7 centimeters long, and we have to figure out how long the hypotenuse is. So I'll leave those up. I'll erase this. So here's our right triangle. Oh, not a good one. This is 7 centimeters, this is 7 centimeters, the right triangle. And then they say C centimeters. So we gotta find the hypotenuse. So how do we start? B squared plus B squared equals C squared. So how long is A? And how long is B? So I'm just gonna write the 7ths. So what's 7 squared? 49. Okay, so there's a long and a short way to getting this done. I'm going to show you both. What would you be inclined to do right now? Add them up. How much is that? 98. And then what do we need to do? Find the square root of 98. So the square root of 98. Now you got to go through this rigmarole, don't you? No, it's not a calculator thing. Perfect. It's a dig through this. Are any of Gesundheit? Are any of these numbers factors of 98? Ooh, yeah.
2. Or no?
That doesn't change the world. That leaves it the same. Any of these factors of 98?
I don't think so.
See, that's no fun. We don't want to have to make it harder work. So here, if I was at this step right here, we think ahead, we know that 49 plus 49 is the same as 49 multiplied by how much? Not by itself, but times 2. And then, when we take the square root, it's the square root of 49 times the square root of 2, which is equal to c. And what is the square root of 49?
Seven.
7. So 7 root 2 is how long that is. That's the exact length. You may live in a calculator world, but calculations that get done in the real world are done like this, and we wait until the very, very end of all of the work to come up with an estimate. So if this is as far as we have to go, then you could estimate this. You could put it into your graphing calculator, you can come up with 9.8 or 9.9, because this is very close to 100. But if this was just the beginning of a big, long series of calculations we had to do, we would leave it like this until we got all the way to our final answer, and then we would change it into a decimal. It's a hard paradigm shift to make, because we're so used to using the calculator. But for accurate work, these exact answers get used. Okay, next one, 48 x squared y squared. So now we're throwing variables into the mix. So we're going to simplify this. Now we're not just looking at this kind of thing, but we are also considering the variables. So there's two steps to this. First of all, to consider the 48. So I'm going to rewrite it like this. I'm going to write 48, and then I'm going to do this. Heck, I'm going to break them all up. So until you start getting real comfortable with these, separate each of the different terms. Separate your decimal numbers from each of the separate variables. So, can you find the square root of x squared? There's a property that you should have written down. The square root of any number squared is equal to the number. You think about it, when we did the square root of 49, that's equal to 7, but 49 can be written as 7 times 7. So what is the square root of x squared? X. And what is the square root of y squared?
What?
It's y. And then now, can we pick any of these pretty numbers out of here to multiply and get 48? 4? 4 times what?
12.
4 times 12. So you could think of this as square root of 4 times the square root of 12. But we can change 12 as well, because 12 is 4 times 3. So this is square root of 4 times the square root of 4 times the square root of 3. And when we see this right here, we know that that's 4. So this is 4 xy square root of 3 for a final answer. Here, and then this turns into 4 root 3. So we can, since this is all multiplication, we just change it so it looks a little prettier. If you wrote 4 root 3, and then times xy, that would be fine. You notice how sometimes I put a little hook on the end of my radicand symbol? If you put a little hook there, then we know that that's where the numbers end that fit underneath. That can be helpful. So, let's see. I have just like a big, huge pile of problems for you on this one. I'm thinking I'd break it up a little bit though. Why don't you try the first 15? There's a lot of just multiplying, simplifying. Number 8, don't get discouraged if that's a challenge, because actually hold off on number 8, because the last example which is given helps to show how you set those kinds of problems up, and it's pretty complicated. So if we were to just look at 1 through 7 and 9 through 15, I think that would be a great start.
This is 502.
Yeah, it's page 502. And I have a quiz for you tomorrow on lessons 4, 5, and 6. But we won't go on to the next lesson. We'll just do a little bit more work in class with this. Gives you a little bit more experience in working with these. These get used a whole bunch on the next lesson as well. We want to be comfortable with square roots before we do lesson 8.
What numbers was it?
So I'd like you to do 1 through 15, but skipping 8. 1 through 15, but skipping 8. Nothing is calculated with this. If it's not a perfect square, you leave it with the square root symbol. With these problems, make sure you write down the original problem so that it can be helpful for you on quizzes and studying for tests.